Greatest integer function question. So as you'll see with something like this, the first thing I want you to identify is that they've given you a graph. You'll notice in here as well that they haven't provided any rule whatsoever. So without even reading the scenario, you can already get started. But let's just give ourselves some context anyway. Cost to park in an airport parking garage depends on time as shown in the graph below. Susan parked her car in the lot for a total of 11.25 hours. If Steve paid $10.50 more for parking than Susan, for how long did he park his car? So with any functions question, and this is greatest integer function, the one thing to evaluate is these guys here. What is the x-axis labeled as? What is the y-axis labeled as? So you'll see that when Susan parked her car for a total of 11.25 hours, that's going to be an x value because that's time. And then they mentioned Steve paying $10.50, so that's basically just a y. Just labeling that is going to be helpful for you to identify what it is we're working with and what we have to solve. So first things first, we don't have a rule. Always, always, always find rule to then use the rule. On something like this, let's start to break things down. Right, we want to have our A and we want to have our K, and we can kind of break things up a little bit differently here. I'm going to put the A with the K just because those are both Y values. I'm then going to put B as well as maybe length. Put that guy there separately. We're going to use that to figure out this rule. And then the last part of this would be the H. So H and K still have a relationship. It's just that to be more clear, A and K are strictly dealing with the y-axis, whereas all of this is dealing with the B, the length, the H is all dealing with the x-axis. You can organize it whatever way you want. This is just to kind of maybe align things in a way that makes more sense. So let's write these things down. So A is always going to be your step height. So in this guy here, right, what is the distance between these steps right here? So we can just count. It's starting at 6. Okay, so I can see right now if I go down to it, it seems like that's starting at 6 right there. And then it's going up to what looks like is 9.5. So in terms of a distance on this guy, we're talking about 3.5 units. So that means my A should be 3.5. Now, in terms of choosing to identify what our K value is in this case, we could choose this point here. This is the vertex, or that is the vertex. Any one of them is fine, to be honest with you. I'm just going to stick with this middle guy right here because I've already kind of been working in that area. And we will just see here, right, that is going to exist right at a y value of 6. So then I just drew those lines there to kind of just get my way to the actual vertex. But let's just clean this up just so it's easier to see for the next parts of this. Now we're going to look at B, length, and H. And really, truly, the way this guy works is I cannot find out what B is until I get what the length is. Those two have a relationship, okay? And essentially, they're reciprocals of one another. So we have to actually find is the length first. If I'm trying to find a rule from a graph, I got to figure out what the length is first. So that one is starting, if I go all the way down here, at what looks like is 0.75. And then it's ending at 1.5. So we can assume that the length is 0.75. So then now for my B value, I mentioned that this is a reciprocal. And so when we're talking about reciprocals, essentially all it is I can figure out what that guy is by just going 1 divided by whatever I had. And now some of you will have interesting calculators that will do this kind of nicely for you. It'll spit it out a little bit prettier if you would like. It might look ugly, right, if we write it out like that. Because 1 divided by 0.75 is going to give me 1.333 repeating. Now, make sure you include that as accurate as possible on your calculator. You can write it as 4/3 as a fraction if you know what your fractions are right offhand. Or you can just make sure that you include like an accurate value when you get to the calculation stage. But that's the meat of this question, is something like that. Trying to figure out how we get our b from the length. So just as a review, I find out what the length of the step is, so 0.75, and I go 1 divided by that length. So that's where that comes from, 1 divided by 0.75. If the length was 3, it would be 1 divided by 3. If the length was 4, it would be 1 divided by 4. Just because we're just taking the reciprocal of these guys. Now, the last part of this is to identify what is my h value. And my h value is going to be aligned with whatever I chose as the k. So when I kind of did that earlier, the purpose behind that was to identify that my k was 6, but then here my h is going to be 1.5. The only thing we have to do now is to identify, based on what this graph looks like, whether A is positive or negative and whether B is positive or negative. And then we'll just assign that to it. As we can see, it's going uphill. If you go to your memory aid, you should have this set up right now. And to be able to identify that in this case, we're going to have an A that is negative and we're going to have a B that is negative. So when I go write out the rule now, so let's write out the rule. You can say f of x is equal to negative 3.5, greatest integer function bracket. Let's include our b value now as we see it, but make it negative 1.333 repeating. X minus 1.5, and then plus 6. So the h is still opposite, the k is still the same on these guys, but we had to manually input that based on the way the graph looks. And essentially what we're looking for is, it was going upstairs left to right, and it went from open to closed. If those two things are true, then we can basically say that the A and B would both be negative. So we now have the rule. We know that Susan parked for 11.25 hours, and we know Steve paid $10.50 more for parking. So we got to figure out how much Susan paid first for her visit. So because that's an X value, that will mean that Y is equal to negative 3.5, right? Negative 1.333. I'm going to keep that as accurate as possible. And then 11.25 as my hours subtracted by 1.5 plus 6. So here, when I'm solving for y, it's actually a lot easier on these ones, mainly just because I have everything I need. It's really now just an order of operations thing. So we always complete like inside the brackets first. What have I noticed is the biggest issue right now is that people are trying to round way too early. Let's calculate what all of that means right now, right off the bat, and then we can kind of get into the actual rounding component. So as in like 11.25, which is the time, minus 1.5, the h that we identified, and I'm going to end up with y is equal to negative 3.5, negative 1.333 repeating, times 9.75 plus 6. Now again, I'm going to multiply this by the most accurate representation of that as possible. And what it gives me, oh, that's weird, is it ends up giving me negative 3.5. I get a negative 13 plus 6. Very rare for that to happen. Interesting to see here. When I want to go get rid of these bars, I never want to have a decimal, so I'm left with a number. It's a whole number. So negative 3.5 times negative 13. It's not going to change because we didn't have to really round it anywhere. It was a negative integer, so it just stayed there. So you'll notice executing the bars just basically means we're executing the rounding component. We didn't need to really round, but I just wanted to show you that like I visibly will demonstrate that the brackets have changed once I've done my rounding to indicate that that has been completed. Now we're just going to multiply that by 3.5 and have y is equal to positive 45.5 plus 6. So Susan spent $51.5. Now we solve for y. Now we got to figure out the x value for Steve. So if Steve paid $10.50 more for parking than Susan, for how long did he park his car? So we are going to end up with a range here. Usually there'll be the question will be phrased a little bit differently, where it'll say something along the lines of, for how long could he have parked, or something like that. But let's just kind of plug that in and solve now. So we're going to include 5150 plus 1050, okay, and then get 61 or 62 on the nose. And I'm now going to plug that in. So solve for x given y is equal to 62. So we use that same rule. And I'm going to have negative 3.5, negative 1.333 repeating. Then I'm going to include an x, the unknown, minus 1.5 plus 6. Now again, our objective is to work our way in to this x value right here. So we are going to try and work our way towards that x value. Meaning, let's do everything on the exterior first before we go anywhere else. What I mean by that is, let's take this 6 and get him out of the way. Let's get him out of the way. So that's going to leave me with, when I subtract the 6 on that guy there, so, and then divided by 56 is equal to negative 3.5, 1.333 repeating, x minus 1.5. We would then divide by that negative 3.5, 5, and see what we get. We get a nice negative 16 is equal to, forgot to include the negative there, negative 1.333 repeating, x minus 1.5. And so those brackets still exist there in that space. So from here, let's take a look at this. Two things to note. Number one, all that is left on this side is just what's inside the greatest integer function brackets. And also, more importantly, all that's left on the left-hand side is an integer. If we had a decimal at this point, there's not really much we can do. We're kind of stuck at that point. But it worked out, so we can kind of move on. We will now, and I'll use the phrase again, execute the bars. So what I mean by that is, this is going to split into two things. And I always do it this specific way. Whatever was inside the brackets, negative 1.333 repeating, x minus 1.5, it's going to be on the left-hand side now. And I'm going to put greater than and equal to negative 16. Perfect. Underneath it, however, I'm still going to put this negative 1.333 repeating, x minus 1.5 on the left-hand side, but it's now going to read less than negative 16 plus 1. And it's always plus 1. This is how we kind of factor in the actual step length. Once I divide by the value of b, I'm going to get an accurate representation for my step length, which is going to give me the range I'm looking for. So now we just solve for x. We have two equations to solve for, and we just complete them both. So divide by negative 1.333 repeating on both sides, okay, which is going to leave me with something along the lines of 12. And here's what happened, which is weird. Whenever I divide or multiply by a negative with an inequality, all of a sudden it will switch directions. There's a reason behind that. I've gone over it in class before. If you want me to go over it again, please just bug me, nudge me, or ask any questions. But for right now, just know when I divide by a negative, the inequality is going to switch. It's still going to be equal to, though. And then I would complete the rest by just adding 1.5 to both sides. X is less than and equal to 13.5. So that is like one part of the range and the final answer here. We would walk through the same procedure again, divided by, and essentially this is just going to become negative 15. Just do that quickly. And my 15 divided by 1.333 is going to give me something like 11.25. So x minus 1.5 is less than 11, or sorry, greater than, it flipped because I divided by the negative, x minus 1.5 greater than 11.25. Add this guy to both sides, bring it over. X is greater than 12.75. So the combination of this and this is now my answer. As in, basically, I can say that it is, let's go this way, 12.75 all the way to 13.5 including. That is like the domain of that step. That is the time period of which Steve could have parked, 12.75 hours to 13.5 hours, if he paid $10.50 more than his friend. So that is a sort of long answer one in a nutshell. Very typical. You're going to either have to find a rule and then use it twice, or some variation of that. But this is a great introductory one to take a look at.